Lists are Python's form of arrays, and they behave very similarly to a JavaScript array. What we're going to do is begin to understand their important features with Python by jumping to the editor and getting started. Okay, so let's begin by showing you how to create a list. Creating a list in Python is really simple. You just type in whatever you want the variable to be, equals, and then you use square brackets and separate every item in the list by a comma. So for instance, here's a list of the numbers 1, 2, and 3. Now we just created a list of integers, but we could also create a list of many different object types. So for example, I could say my list and have it hold some string stuff, maybe some more numbers, integers, some floating point numbers, and then later on we'll see how it can hold booleans and more. So again, we can have mixed data types inside of a list, and we can even have a list nested inside of a list. So this is totally good code and it will work. So let's actually run this to verify that. I'm going to call Python, and then I call this script list.py. Hit enter. We don't get anything out because we didn't print the list. So we can do this, print my list, and let's comment this one out. Again, that's just command /. Hit enter, and we see that the list has no problems being printed out. And just like a string, we can call the len function on it, so length of my list. And let's now use the more normal list, 1, 2, 3, and actually print out that length, and we see we have 3 items in the list, 1, 2, and 3. Okay, indexing and slicing works basically the same as it did in a list, or excuse me, in a string. So I'm going to redefine list to be A, B, and then, whoops, comma C. If I want the very first item in the list, I just have to use mylist 0. So let's print that out and confirm. This should return A. So if I run this, hit enter, I get A back. If I wanted C, I could just say -1, and that would give me back the last item in the list. And to add a couple more terms in here, so we can see how slicing works, not just indexing. If I have A, B, C, D, E, if I want to grab everything starting at index 1 all the way to the end, again it's just 1, and that will give me B all the way to the end. Or if I want everything from the beginning up to but not including index 3, so this should be ABC, I get a list ABC. Alright, now let's talk about actually adding items to a list. Unlike a string, lists are mutable, meaning I can say my list, grab the item at index 0, and set it equal to something totally different. So let's say new item here, and let me print out my list. And let's print it out before. So we'll say before reassignment, and then print my list, whoops, not as a string, as the variable itself, and then we will print after reassignment. Save this, run the code, and here I can see before reassignment I have A, B, C, D, E, and then with line code number 5, with this reassignment, I have new item B, C, D, E. And that just puts the point forward that we can actually do reassignments with index calls on a list, defining it as a mutable item. Okay, now let's talk about some basic list methods that you may find useful. If you want to add a new item and have it be appended to the very end of a list, all you have to do is use the append call. So I can say my list, and you can see the very first one here is append, so we can select that, and then you can append any item to the list. So I can say something like new item, and this will not affect any current item in the list, it will just append it to the very end of the list. So now let's print my list after we append it. So I'm going to save, run this again, and here I can see my list was now A, B, C, D, E, and then new item was appended to the very end of it. If I end up appending a list to this, so let's say I have a list that says X, Y, and Z, just to make this clear. Note my brackets here, so I'm actually appending a new list to the end of this. What's going to happen is that now this very last item completely is a list. if you actually want this list to be a part of the original, what you have to do is not use append, but use the extend method. And then we can, let's just actually put this to a new variable. So we'll say list2 is equal to that list, and I'm going to, instead of appending something, I will extend it. Save this. So note the difference here. This was with append. That means the very last item is the list, so I have a list nested inside of another list. If I use extend instead, and then print out the list, then I actually extend the list to include all these items right here. So note the bracket difference between append and extend. And you only use extend when you want to extend another list with the original list. So we've talked about adding things to a list, but what if you actually want to remove something from a list? Well, the most common method for removing something from a list is the pop method. So I can say mylist.pop, and basically what this does is it grabs the very last item from a list and returns it. So we'll call this item and then say print mylist and print item. So what's going to happen here when I run this is my original list was A, B, C, D, E. Then I popped off the very last item in the list, saved it to the variable item, and then when I print out my list, E is now gone, and item is now that letter, E. If you do not want to grab from the very end of a list, you can actually specify an index position in pop. So this can be any integer index position as long as it's in the list. So if I put 0 here, now it's going to pop off index 0, which is A. So let me run this again, and now I see B, C, D, E, and I have A as my item. And that's the pop method. And keep in mind, pop method returns an item. Two more useful methods that you may find yourself using are reverse and sort. So if I say mylist reverse, close parentheses, and then actually print out my list, then I will get a reversed version of the list, EDCBA. And something that's interesting to note here is that this occurs in place. And what I mean by in place is I didn't have to save this to another item to see the change effect. All I had to say was mylist.reverse, and my list was changed in place permanently. So then when I reprinted my list, it ended up being in reverse down here. So that's reverse, and then let's create a list here with a bunch of numbers in it, some random numbers, and instead of reverse, what I'm going to do is ask for sort. And if I save that and run this, it will actually end up sorting that list. So Python has its own rules for sorting things, especially if you have multiple data types in there, like strings and numbers. It has a specific hierarchy, and you can check out the Python documentation if you find yourself needing to know that hierarchy. But for the rest of this course, we won't be dealing with sorting mixed data type lists, and it's actually bad practice to do that because it's unusual to have to do that operation. You should try to have only one sort of data type for a single list. Okay. Finally, I want to mention two more topics, which is a nested list index and then a list comprehension. And we'll cover list comprehensions in much more detail later on, but I want you to be aware of them now, since they may be confusing to beginners. But if I have a nested list, so we'll say my list is 1, 2, and then the third item in the list is going to be X, Y, Z. If I call print my list and I'm looking for the third item, so at index 2, what's going to happen when I print this is I get this entire list back. So if I run this right now, I get X, Y, and Z. Imagine that I'm only looking for the letter Y. All I have to do here is add another set of brackets to actually index this list that was returned to me. And Y is at index 1, so I just put the number 1 here, save it, run this again, and now I get the letter Y returned to me. And that's how you can index a nested list. And you can do this with a nest within a nest within a nest. That's not too common. You usually only have to do 2 levels at most, but keep in mind this could keep going over and over again depending how many lists you had nested inside of another list. So that's nested list indexing. And finally, I want to show you list comprehensions. So to do this, I'm going to create a list called matrix, which is going to be a nested list. So this will be 1, 2, 3 as the first item, 4, 5, 6 as the second item, and then 7, 8, 9. So right now I have 3 lists inside of a single list. So there's only 3 items in matrix, but each item is 3 more items in the list, which means I can do something like matrix 0, 0, and that counts as 1. So it's the very first item here and the very first item of that item. Now for a list comprehension, it's basically going to be like a for loop, but flattened out into a list. So if I want the very first column, what I could do is say row 0 for row in matrix. And we'll be covering list comprehensions and for loops in a lot more detail later on, but I just want to show what's possible with Python and how you can make really clean looking Python code. So then I'm going to print first call, save this, run this Python list, and now I see I have 147. So what is actually going on here? Well, I'm saying for row in matrix, and row counts as each item in the list, so it's saying for this one, and this one, grab the very first element. So grab with bracket index location, element 0. So then it returns 1, 4, and 7. So this is a for loop, basically flattened out into a list, and it's inside brackets, so it ends up returning a list itself. And this is known as list comprehension. And we're going to be covering this a lot more, but this is definitely something you're going to see all the time with Python. It's a great tool, and as you begin to get more advanced with Python, you yourself will be using it a lot. Alright, that's all we need to know about Python lists for now. Thanks everyone, and I'll see you in the next lecture.